Welcome to FTO Insights 001. Today we're bringing you an explainer on a massive foundational shift happening right now in our industry.
Absolutely. If you're a startup founder, a CTO, or a technical architect, you're already feeling the tremors. Today, we're cutting straight through the hype with an analytical teardown of the actual on-the-ground reality of AI in software development. We're skipping the marketing noise to focus purely on the architectural requirements of building production-grade products today.
So let's just dive right into the paradox that engineering teams are wrestling with every single day. If our AI coding assistants can literally spin up thousands of lines of code in seconds, why are we still seeing software projects getting delayed? Why are they still blowing past budgets? And why is the code base suddenly becoming an absolute nightmare to maintain?
Yeah, it's the ultimate hook, right? We've supposedly given developers these incredible superpowers, but project velocity hasn't exactly scaled proportionally. We have to acknowledge that while these AI tools have completely transformed how fast we can type out syntax, massive code output simply does not equal project success. I mean, we've all seen it. A developer uses an LLM to spin up a whole microservice in an afternoon, but then it takes the team 3 weeks to debug the integration because the model hallucinates database schemas and completely misses the legacy authentication flows.
Which brings us to Section 1, the AI coding paradox.
You see, there's a massive kind of unspoken disconnect in the tech world right now. We're consistently confusing the act of typing with the act of architecting. We can map out this dichotomy by looking at implementation versus architecture. On one side, we have writing code. Now, this is pure implementation. It's syntax, it's localized logic, it's writing that perfectly optimized sorting algorithm or a really clean API endpoint. In AI models, they are exceptionally good at this micro-level task. Right, but contrast that with building products. This is the macro level. Building products requires deep business context. It demands strict governance over data and security, a robust understanding of system architecture, and an anticipation of really complex user needs. Sure, an AI can write a syntactically beautiful React component, but does it know if that component actually aligns with your specific enterprise design system? Does it know if the state management violates your SOC compliance? Usually the answer is a hard no.
Moving on to Section 2. Software is more than code.
We really need to zoom out here. We have to stop looking at the single, isolated function in our IDE and start looking at the entire production environment. Because honestly, that's where the real bottlenecks are happening. Standard AI models are fundamentally failing to address the unseen challenges of real-world software engineering. Let's break down the 3 massive pillars of this. First up, knowledge management. This is how you track decisions, state, and business logic across a distributed team.
Exactly. When an AI doesn't know why a specific architectural decision was made 3 years ago, like say why a specific queuing mechanism was chosen to handle peak load, it will happily rewrite it in a way that just breaks under pressure. Then look at the second pillar, continuous validation. It is not enough that the AI's code just compiles. Does it break downstream dependencies? Does it inadvertently introduce a race condition into an entirely different microservice?
And then we have the third pillar, system orchestration. Managing the complex dance of deployments, infrastructure, and legacy integrations. Standard LLMs are largely stateless, They are completely unaware of these massive environmental factors. They literally don't know that touching a specific legacy integration is going to cascade failures across your entire payment gateway.
So it all really comes down to this foundational architectural truth. Software engineering extends far beyond writing code. And honestly, ignoring this fact is exactly why we're seeing so many teams struggle right now. They're trying to solve massive architectural and orchestration problems with tools that were only ever designed to write syntax. It's kind of like trying to build a skyscraper using only a really fast hammer. This is exactly why an entirely new system layer is desperately needed to bridge that gap.
That brings us to Section 3, why engineering systems matter.
If we agree that AI is incredibly fast at writing code, but lacks that necessary macro context we just talked about, well, then we have to talk about the absolute necessity of robust engineering systems. Because without them, you aren't just moving fast, you're moving fast in the exact wrong direction.
For sure. Without system architecture and governance, scaling AI output leads directly to unmaintainable technical debt. Just think about the compounding effect here. A junior engineer writing poorly structured code, that's a manageable problem. You catch it in a pull request, no big deal. But an AI model generating poorly structured, contextless code at 10 times the speed of your fastest engineer, that is a localized disaster. Speed without governance inevitably, mathematically, causes project failure. You're essentially automating the creation of technical debt, and somebody is going to have to spend weeks untangling 50,000 lines of ungoverned, unvalidated AI code.
Which leads us into Section 4, Founder Development OS. Now, we can't just sit here and admire the problem all day. We're engineers. We need a solution. we realized that the industry didn't need yet another coding assistant. It needed an entirely new layer of infrastructure to manage the assistants. That's where Devolopment OS comes in. It's an engineering operating system, specifically designed to manage knowledge, context, governance, validation, and orchestration, while AI models focus purely on implementation. Exactly. By abstracting all of that highly complex macro-level work into a dedicated operating system, we actually free up the AI models to do exactly what they excel at. FDO acts as the master conductor. It sits above the individual tools, ensuring the AI orchestra is actually playing the right symphony rather than just generating noise.
Let's get into the technicals. Section 5, the FDO architecture.
For all the technical architects and engineers joining us today, let's progressively build out how this system operates under the hood. We want to show you exactly how we safely deploy AI at scale. It all initiates at the very top with the human intent, the founder vision.
Right, and instead of going straight to an LLM, that raw human intent is intercepted by the Devolopment OS. The OS wraps that intent in your strict engineering context. We're talking about your existing codebase, your strict architectural rules, and your historical business logic. Only after it has been properly packaged does it hand off to the orchestration engines, and then finally it reaches the LLM implementation phase. This entire pipeline guarantees that human intent is safely translated into managed, context-aware AI execution.
Let's actually dive a little deeper into the internal flow within those orchestration engines, because this is where the critical governance happens before a single line of code is ever touched. We have a very strict internal flow here. First up is the loop engine, which basically handles the iterative breakdown of complex engineering tasks into digestible logical units. From there, that passes directly to the evaluation engine. You can think of this as your automated draconian gatekeeper. It tests the proposed logic against your specific architectural standards. So for example, it ensures the proposed code doesn't violate your SOC 2 compliance or inadvertently break your existing API schemas. If, and only if it passes that strict governance, it moves to the model adapter. That adapter formats the validated request for whichever specific model you're running, whether that's OpenAI, Anthropic, or a custom open source alternative.
Ultimately, what this all comes down to is a strict separation of concerns. FDO is entirely responsible for context, governance, validation, and orchestration. It holds the memory and it enforces the rules. Meanwhile, your AI models, Claude, GPT, Gemini, whatever flavor you prefer, are relegated strictly to what they do best: implementation, syntax execution, and localized logic. You wouldn't ask the engine of a car to decide where to drive, right? You just ask it for power. This strict separation of concerns really proves why AI fundamentally needs an operating system to function effectively and safely at an enterprise scale.
Which brings us to our final section, Section 6, the future of AI engineering.
We've covered a lot of ground today, looking at the limitations of raw AI output and the deep necessity of structural governance. But what does this actually mean long-term for startup founders, CTOs, and product builders? Well, it synthesizes down to one simple truth. AI models are the engine. They provide incredible, truly unprecedented horsepower. But the Devolopment OS, that is the steering wheel. Power without control is entirely useless in software engineering. In fact, as we discussed earlier, it's highly destructive. To build scalable, maintainable products in the future, you are absolutely going to need both: the raw horsepower of the models and the strict directional governance of the operating system.
Which brings us to our closing mandate for all the builders watching today. Connect, build, validate, evolve.
We want to invite you to reflect deeply on the future of your own AI-assisted development workflows. Take a hard look at your processes and ask yourself, are you just typing faster, or are you actually engineering better?
It's a crucial question. We encourage you to follow the FDO journey as we continue to build this critical infrastructure layer. Thank you so much for joining us for this explainer. Until next time, stay focused and keep building.